Let's summarize it. So we have so far the R1 equals 2 over 3, R2 equals 0, and the recurrence relation is ck plus 1 equals ck divided by k plus r plus 1 multiplied by 3k plus 3r plus 1 for k greater than or equal to 0. And then we're going to work on 1r at a time. So for r1 equals 2 over 3, the recurrence relation ck plus 1 is in the form of ck divided by k plus 2 over 3 plus 1 times 3 times k plus 3 times 2 over 3 plus 1. And we see this as k plus 5 over 3 multiplied by 3k plus 3. So 3k plus 3, and we factor it to be k plus 1 multiplied by 3. And simplify by multiplying 3 to the first group, to get 3k plus 5 multiplied by k plus 1 as the denominator. So we rewrite the recurrence relation for R1 equals 2/3 as ck plus 1 equals ck divided by the product of 3k plus 5 and k plus 1 for k greater than or equal to 0. And then we use this recurrence formula to find the coefficients C1, C2, C3, and so forth. So for k equals 0, we obtain C1 as C0 divided by 5 times 1, or 1 over 5 times C0. For k equals 1, we get C2 equals C1 over, so the term gonna be, the bottom is 3 times 1 plus 5, which is 8, multiplied by 1 plus 1, that is 2. So we get 1 over 8 times 2 times C1. And where the C1 is 1 over 5 times C0, we get 1 over 16 times 5, which is 80 C0. Another term, k equals 2, we get C3 equals C2 divided by, another term gonna be 11 multiplied by 3, which is 1 over 11 times 3 times C2, and C2 is 1 over 80 times C0, or we get C is 1 over and the number 33 times 80, which is 22640 times C0. Now we're gonna put them together as a power series. So we get C1 as C0 over 5 times 1, C2 as C0 divided by 8 times 2 times 1, 8 times 2 times 5 times 1, and C3 as C0 divided by 11 times 3 times 5 times 1 times 8 times 2 times 5 times 1. And then you can see the pattern as 11, 8, 5, and the other one is as 3, 2, 1, which is the factorial. So we can rewrite this 3, 2, 1 as a 3 factorial, and the 11 times 8 times 5 as the 3 multiple plus 5. Okay, similar to the C3 here as 8 times 5 times 2 factorial. And 11, 8, 5, that is the multiple of the, what is this called? The 3n plus 2. the 3n plus 2, the 3 times 3, that's 3n plus 2 times 3n minus 1 times and so forth until we get 8 and 5. Something like that. So then with this, we have the first solution y1 as x to the power r multiplied by the summation cn x to the power n, n from 0 to infinity. And since r equals 2 over 3, we get x to the power 2 over 3 multiplied by c0 plus c1 x times c2 x to the second plus c3 x to the third and so forth. We write it as x to the 2/3 multiplied by c0 and c1 as c0 over 5 factorial or 5, c2 as 1 over 80 times c0 times x to the second, and c3 is 1 over 2640 times c0 x to the third and so forth. And then as we take the c0 out, we have c0 multiplied by x to the 2/3, and then we have the power series in the quantity of 1 plus 1 over 5x plus 1 over 80 x squared plus 1 over 2640 x to the third and so forth. So this is the first solution in the power series form from the first R. And then next, we're gonna use the second R value. For R equals 0, and then the ck plus 1 or the recurrence relation is of the form ck divided by 3 times k plus 3 times r, which is 0, plus 1 multiplied by k plus 0 plus 1, or in the form of ck divided by 3k plus 1 multiplied by k plus 1 for k greater than or equal to 0. Now for k equals 0, we obtain c1 as c0 divided by 1 multiplied by 2, 1 multiplied by 1, or just c0. And k equals 1, we get c2 equals c1 divided by 3 times 1 plus 1, that's the value 4, multiplied by 2, or 1 over 8 times c1, which is the same as 1 over 8 times c0. So k equals 2, we get c3 equals c2 divided by 7 multiplied by 3, or 1 over 21 times c2, and c2 is 1 over 8 times c0. And then simplify this to be 1 over 168 times c0. Now put in the power series form as a second solution, y2 x to the power r, which is power 0, multiplied by the summation of the cn x to the power n, n from 0 to infinity. X to the power 0 is 1. Therefore, we have the y2 in the form of c0 plus c1, which is 1 over 8 c0 times x, and plus 1 over 168 c0 times x to the second, and so forth. Factor the c0 out, we have the fundamental solution as 1 plus 1 over 8 times x plus 1 over 168 times x squared, and so forth. And with this pattern, we can find the general solution as c1, c0, 1 times 1, and you see 1, 1, 2, 3. So we can see the pattern of the n factorial. And 1, 4, 7. So 4 is 3 times the value 1 plus 1 more. And 7 is 3 times 2 plus 1. So we're going to have the number as 1 times 4 times 7 times 11 times 10 and so forth, as you keep adding by the value 3. So in summary, we have the power series solution form of this problem as c the first C0 times Y1 plus I call the second as a C0 square, C0 star times Y2. And the first one we get as C0 multiplied by x to the 2/3 multiplied by 1 plus 1 over 5x plus 1 over 80 x squared plus and so forth. And the second solution as the sum of 1 plus 1 over 8 times x plus 1 over 168 times x squared plus and so forth. And the first one here is the first solution y1, second is second solution y2. And we can see the power series solutions as a sum of the two linearly independent solutions.